Hey, my name's Steve Demig. I'm a Python developer looking for some freelance gigs, and I have been doing this series of videos on software development. And the last three or four, I've developed this app called a stock analyzer, which basically uses automation and web scraping to fill in data based on like a stock or a company you want to research. So it'll look at it'll search the name. It uses GTP to write a description of it. Well, let's take a look at the diagram. It'll show you. So basically the user over here will enter the name of the company they want to search through the JavaScript front end. It sends a REST API to the back end, and it'll scrape the data like it'll go to ChatGPT to look to write a little description of the company based on the name, right? So it can figure that out. It get the logo from this place called Brands of the World. It gets stock information from this stock analysis website, historical data from Polygon, and then it scrapes for sentiment of comments on videos and posts from both Reddit and YouTube. So it has two social media platforms that it looks for sentiment on. Okay. Previously, we wrote all that. So we wrote this whole front end piece and the back end piece, and I showed videos on that. Now we're going to add observability. So on a previous video, we did another observability video using something called the TIG stack, which is Telegraph, InfluxDB, and Grafana. This one we're going to use OpenTelemetry. OpenTelemetry is a standards-based observability framework. A little more complicated to set up and get working, but it's more powerful, and you could, more flexible and powerful in the long run. So if you're gonna, short term, you want to get something going, you have some, like you just want to look at, say, basic metrics like CPU or whatever on a single box, or maybe like 3 or 4 VMs. Telegraph, hey, that probably works. A TIG stack works okay. But if you're getting more serious, you want to start really considering OpenTelemetry, simply because you're a lot more flexible. Like that middle piece, that OpenTel collector container showed it's going to send traces to Tempo and metrics to Prometheus. Well, you can swap those out and say send metrics to InfluxDB, traces to Jaeger. You can do all that stuff just by very simply, without having to do anything to your application. You can change your OpenTel collector config, and boom, you're all of a sudden using a different backend for traces and metrics, just like that, right? So very powerful approach to it. Just a little more complicated, I'm warning you, than setting up a TIG stack. So we're going to say, what is OpenTelemetry? It's an open source observability framework that provides a uniform standard for collecting, generating, and exported telemetry data. And the telemetry data is basically traces, metrics, and logs. So let's get into that. The big thing about being standards based is it can work with various downstream processors, right? Splunk, Datadog, like I said, Jaeger, InfluxDB, Tempo, and Prometheus from Grafana. It can interop with all those different downstream processors without seamlessly. It does seamlessly. So that's what's nice about being standards based. It's not proprietary. One thing you got to do one way for Splunk and then another way for Datadog. None of that. It's one way, and you get all those different processors downstream. So the OpenTelemetry types, a trace is a path of request through your application. So say you hit a endpoint on your API, it's going to show you all the steps it took to process that request, right? So you're going to be able to see that, a timed path through your application. Very powerful, right? Metrics, it's going to give you counting statistics, like say the amount of CPUs, the number of each type of request received, that type of thing. Raw logs, you can send raw logs and you can process them, all the different downstream processors. You can basically look at the log with a regular expression or different things, and you could grab meaningful information from them. So it'll do it basically, OpenTelemetry deals with those three types. OpenTelemetry collector, that's the piece that sits in the middle there. It's a powerful piece. It's a vendor agnostic open source data pipeline for traces, logs, and metrics that receives transforms and exports data to one of the observability backends, one of the downstream processing backends. So you can use it to, basically you can receive data from your application, you can process it by manipulating it in various different ways, and you can export it to your downstream processors. Similar product is Telegraph. Yeah, kinda, but Telegraph is very limited on what it does, and this is much more flexible. Tempo. Grafana Tempo is an open source high volume distributed tracing backend designed for storage and management of traces. Similar product is Jaeger, Zipkin, or Datadog, so they all deal with traces as well. So this is just like a version it's pretty much tied to Grafana. I haven't seen Tempo used with any other thing besides Grafana, but with Grafana it works pretty well for doing your traces. Prometheus is your time series database, the data collection piece of this. So it's used to store metrics. We're going to store metric data in Prometheus, and we're going to be able to query it using something called PromQL. So it's a SQL-like kind of, sort of, not really, but a querying language that you can use to query metrics. Filter them, do all kinds of things with them, do operations on them, like sum them, average them, all that kind of thing. PromQL allows you to do those things. Similar product, InfluxDB, very similar, really. So those two things are really pretty similar. They both have, languages. PromQL and InfluxDB has one as well. I forget what it's called, but has one similar type of concepts. Grafana is your visualization piece of this solution, so that it's going to be used. It's going to be the thing that we're going to view our dashboards, right? So Grafana is where we create, and you could view your dashboards. You can also do alerts through it. We don't do that here, but like say a certain metric dips below a certain threshold, you can detect that and send an alert, either email, or you could send it to a hook, a webhook, or you could send it to like a Teams chat or a Slack chat, right? So you can do all those kind of things with alerts. Those are powerful as well. But we're just looking at dashboards here. So if you remember what the stock analyzer looks like here, it's kind of like you enter the name of a common name of a company. You can select multi-threaded or single-threaded and hit submit, and it's going to come. It's going to give you the sentiment. Don't worry about that 0%. My quota for YouTube was exceeded, so it's no longer grabbing stuff from YouTube right now. Tomorrow it will, right? So it's going to give you stuff like, the name of the company, the common name of the company, the ticker symbol, the current closing price. It's going to give you the logo. It's going to give you a short little summary of the company that ChatGPT wrote. It's going to give you the historical stock performance over time, the last 12 months. It's going to give you that based on some data from Polygon. So what we do here to load our Prometheus database up in our Tempo with traces is, instead of one by one through the UI hitting a bunch of companies, we got some automation set up with Playwright. Let's see what that looks like. So all it does is it hits our 10005 there, localhost, so it hits our UI over and over again, and it's gonna basically select multi-threaded. It's gonna input the target string, and it's gonna hit submit, right? So it's gonna hit that submit button. It's gonna fill in this data. It's gonna select multi-threaded, fill in this data, and hit submit. That's what it's gonna do over and over again. On a file that contains just a bunch of company names. So what do we got here? I know I got it somewhere. Profile is what it's called. Profile.txt right there. Okay. So it's got a bunch of company names in here. It's going to take this whole list, and it's going to do a random distribution over all these guys. You notice some of them are selected multiple times, so it makes a more interesting graph if some are higher and some are lower. So you're going to see stuff like that, right? So NetApp's going to get chosen more. Caterpillar and Verizon, they should be your top hitters. That's how it works. So we go to Grafana. All right, and we take a look at, you see we're looking at the last 24 hours of data. we can see that we have a success rate. Not all of the queries succeed. So, when you're scraping data from websites, sometimes those websites go down, other various things happen. Sometimes you're not going to get a success when you're scraping data. 100% would be something you really can't expect from this type of application. So as you can see, like over the last 24 hours, and it's very low volume, we're getting about a 98% success rate. So we're getting, 2 errors out of every 100 queries is essentially what's going on. We can see the companies we're searching and querying for. So our top searches are NetApp, Verizon, and Caterpillar, just like we saw in that file. And, you can see the tabular representation over here, and you can see a donut graph over here. You can see the kind of like a little history of what's going on. It's increasing over time. Next thing you can see is like the traces through your data. Each one of these functions, we're going to tell you how long we took in them. So you can see what's your bottlenecks. We're going to be able to see bottlenecks. We're going to be able to identify bottlenecks in code by the tracing that we get from our apps. This little histogram over here, how you read this, is these buckets over here, like from 0 to 8 seconds or 0 to 8 seconds. That's any method that falls in here is going to take that short amount of time. All these up here are like 72 seconds or above, right? So that's a minute to execute that thing, right? So the extract comment thread data and the get all data, they take a long time. So they're way over here on the right. These guys over here, transform comment thread data for Reddit and extract comment thread data, they barely take any time, so they're over here on the left. That's how you read that. This as well, you're going to be able to see if you got stuff showing up here over here on the right, you're going to be able to identify bottlenecks just by looking at this dashboard. Glancing at it, we'll be able to see it. Glancing at this error rate, we'll be able to see if there's problems going on. Glancing over here, we'll be able to see who our top hitters are. We'll be able to see, who's really popular and who's not at our website. Here's what a trace looks like. So down here is our actual raw traces. And if we select one and take a look at it, leave page. Okay, we're going to be able to see that trace. So we go into Stock Analyzer. We go to the get all data call. That's the call that gets called at the root of every multi-threaded query. All right, so the first thing we do is we're going to get the logo, a description from ChatGPT, stock info and stock data from Polygon. We're going to extract search data for YouTube and Reddit, and we're going to do, transforms on that data, etc. So you're going to be able to see all those steps as well as the amount of time each one took through this trace. Very powerful, right? So you're going to be able to visually see all the things that went into taking the amount of time it does to perform your work. So, you're going to see right away that extract comment thread from Reddit is taking the longest, right? So it's your bottleneck, and it's expected, actually. I mean, it's expected because that's your API query. That's going to take a long time. All right. The metrics on this. All right, so let's take a look at our metrics. So there's really only this uses something called span metrics. So it takes those spans and generates metrics from it. You wouldn't be able to think you'd be able to get all the application metrics you need from that. Like there's 3 metrics. There's one that counts the total number of calls to a particular dimension of a metric, etc. One that takes the amount of time. That's what we're using over here, right? You wouldn't be able to think you'd be able to get everything, but dimensions is what does it, right? So, okay, let's go back and look at that trace here real quick so I can show you. All right, so these things have on them, each time we get into this get all data call, we tag it with a span attribute. You're going to be able to see that. And so it's got a span attribute called target query, and this one's set to Verizon. All right, so we're going to be able to use that span attribute, and then we're going to be able to look at it just like it's a target query metric. So this call data metric is now a target query metric, right? It's going to be able to tell us how many times that target query got called for that value for Verizon. By using these span attributes, you can create any metric you want for your application, essentially. So you think you're limited to 3, but really with dimensions you're limited to n, an infinite number, right? So you could just do whatever you want with these span attributes to create metrics for your application. I'll show you how metrics look in a dashboard. So we go down here. This is what PromQL looks like. That's PromQL right there. So floor call is being made, a sum by target query. So we're summing by all the different values in target query, Verizon, NetApp, Caterpillar, Home Depot, etc. We're measuring the increase of those. So we're going to be able to see from the beginning of that window, 24 hours, to the end, how much it increased. That's what we're measuring there. And so that's going into our donut here. That's how you do it, right? So I could come up with different dimensions here and export those, and you'd be able to see those and use those in dashboards as well. So it seems like it's simple and that it won't work, but no, it's actually powerful, and you could use it for whatever you want. Okay, let's take a look at just a little bit of code here. Show you how things work. Let's see, decorators. So this decorator here does all of your span tracing. So basically we set up a decorator that will do all this open telemetry work so your application doesn't have to. So it sets up the initial span, it records the span, it does all that kind of stuff, gives it a status at the end, whether it's successful or not. You don't have to worry about doing any of that, right? So you just write code that looks like this, that uses the span decorator on your code, and it'll do all that stuff. Here you can see that we're setting the attribute, right? So we're setting the target query to whatever the value of that thing is. So it'll come in and it'll set it to Pepsi or Tesla or whatever you're querying. That span will have the correct target query dimension for it. So that works out really well. That's about it. You can see there's a bunch of config files, right? So you have a config file. Your main config file is this OTel collector config. This was the trickiest one because I didn't really know the difference between a receiver or exporter. It caused me some time. But once I understood that and what I was doing with those things, it was much easier. And then, it sets up your span metrics down here with your histogram buckets that we viewed on that previous dashboard. And these are the dimensions you're allowing through. So that's one thing I don't like about it is to get a new dimension, you're going to update your config file and rebuild and redeploy. That's what you're going to have to do. So at an enterprise level, we used to do that like real early in the morning. If we were having any updates, we'd deploy those real early in the morning. It really didn't have a lot of effect, but it does have some effect. You got to plan for it. Then you have a tempo config file, right? Defines your gRPC ports, your HTTP ports, etc. You have a Prometheus config file, and you have a Grafana data source that gives your tempo data source right there. You also have the Docker Compose, right? Docker Compose. Shoot. Yeah, there we go. Yes. And it's now I was using environment variables for secrets, and that's bad. So now they're using a mounted secrets file. So that's good. You don't have to worry about anybody snooping those. We're all good for security-wise. Exposes the various ports, all that different kind of stuff. So we're good with that. And that's about it. That's about all I got for this. It's fun to do. Open telemetry, very powerful. And like I always say, good luck. Thank you. Good luck in finding a good developer to work with via freelancing. I hope it's me, right? Just telling you the truth. I'd love to work with you. I'll work for cheap. So just let me know. And I like doing these things. I'll keep doing them. So thank you. That's it.